Hey everyone, and welcome to another deep dive. As AI students, things move pretty fast in our world. So today we're diving deep into something particularly interesting, alpha geometry 2, or
Yeah.
AG2, as I'm sure you're already calling it. Remember its predecessor, alpha geometry? Well, AG2 takes things up a notch, actually a lot of notches. It's achieved superhuman performance.
That's right.
It's now better than your average human gold medalist at the IMO. Pretty wild, right?
It really is. It's remarkable what they've achieved with this new system.
So we're going to unpack how exactly they pulled it off.
Mm-hmm.
What are these big upgrades? Why should you care?
Well, I think one of the things that's most striking about AG2 is just how much they've improved the core components. It's not just that it's faster, which it is, it's that they've made some really clever enhancements that have pushed it into this realm of superhuman performance.
Okay, so let's break down those enhancements. What is it that makes AG2 so special? What are we looking at here?
Well, first of all, it can solve a whopping 84% of IMO geometry problems from the last 25 years, which, if you remember AG1, the first one, had a 54% solving rate.
So that's a huge EE improvement.
Massive.
Yeah. Just imagine if you had a study buddy who could solve pretty much any Olympiad-level geometry problem you threw at them. That's AG2 for you. Like having a gold medalist on speed dial.
Exactly. It's like this incredible resource. One of the things that allows it to perform at this level is that they've really enhanced its understanding of geometry. They've given it this expanded domain language, so it can actually grasp more sophisticated concepts.
Can you give an example of what you mean by expanded language? Like, how does that actually manifest itself?
Sure. So, for instance, AG2 can now handle things like locus problems, which are these problems where you're dealing with points moving on paths. AG1 really couldn't handle those very well. But they've added these predicates to the language specifically to represent things like that. So you could say, as point X moves on this circle, point Y will always stay on this line. AG2 can represent that explicitly.
Oh, that's interesting. So it's like AG2 has become fluent in geometry, like it's
Yeah.
speaking the language even more deeply.
Yeah,
Yeah.
exactly. And it's not just about understanding the problems better, it's also about being able to do more itself, right? So they've significantly automated tasks that previously required manual work.
Oh, okay. So what does that mean? What kind of automation are we talking about?
Well, for example, it can automatically translate word problems into its own language, like a formal language, which it can then work with. And even more impressive is it can now actually generate the diagrams for the problems, which used to have to be done by hand.
Wow. So that feels like a pretty big shift, right? I mean, what are the implications of that if it's now doing all that work itself?
I think it represents a really important step towards more autonomous AI problem solving, right?
Yeah.
Because it's becoming more independent.
Hmm.
And I think that opens up all sorts of possibilities for maybe tackling even more complex problems in different fields as well.
It's becoming more of a mathematician in its own right, in a way.
Yeah, in a way.
And that idea of automation, I feel like that's a trend we're seeing a lot of, right?
Oh, absolutely. I think it reflects this kind of broader push in AI where we're trying to automate these sort of tedious, time-consuming tasks so that the AI systems can really focus on that higher-level reasoning, problem-solving.
That makes sense. And speaking of reasoning, DDAR, that symbolic reasoning engine that was at the heart of alpha geometry, that's gotten a pretty big upgrade in AG2 too, right?
Oh, yeah, absolutely. So it's gotten both faster and smarter. Remember that issue with AG1 and the double points where it couldn't handle situations where you had 2 points that had different names, but they were in the same location?
Yeah. Like they were the same point, just called different things. It's like synonyms in language.
Exactly. AG2's DDRR has fixed that problem, which makes its reasoning a lot more flexible and robust. And they've also made some really cool algorithmic refinements and implemented it in C++. So it's a lot faster now.
So it sounds like they really thought of everything with this upgrade.
It does seem that way.
And I'm curious, the data that it's learning from, is that the same as AG1?
So actually, no, they made big changes there too. AG2's language model was trained on a massive data set of geometry problems and solutions. And get this, it's all synthetic data.
Synthetic, so it's not real human-created problems.
Exactly. They created an algorithm to generate this huge data set, which gave them a lot of control over the diversity and the complexity of the problems.
So it's like AG2 is being taught from this custom-made geometry textbook written by an algorithm.
Pretty much, yeah. It's a really interesting approach, and it really highlights this whole idea of using synthetic data for AI training because it gives you this level of control and flexibility that's really hard to get with real-world data.
It's like having a personal tutor for AG2. That's really neat.
Exactly, and it allows them to create these problems that are like perfectly tailored to what they need the AI to learn, which is really cool. And when it comes to actually solving the problems, you might be wondering, how does AG2 search for those solutions? Remember, AG1 used beam search.
Yeah, beam search is a big deal.
Right. Well, they've actually taken it a step further. In AG2, they're using this really cool method called Skest, which stands for Shared Knowledge Ensemble of Search Trees. It's like this multi-pronged approach where you have a bunch of different search strategies all kind of working together and sharing what they learn along the way.
So it's like they have this whole team of search strategies, and they're all brainstorming. They're all like, hey, I found this. Hey, what about this?
Exactly. And it's actually, in a way, it's kind of how humans solve problems too, right? We bounce ideas off of each other, we get different perspectives, and that often leads to breakthroughs.
Yeah. Teamwork makes the dream work, even in AI. And of course, we can't forget the language model itself.
Oh.
I've heard AG2 is using Gemini, the big one everyone's been talking about.
Yes. So they actually experimented with different approaches for the language model. They tried training one from scratch. They tried fine-tuning an existing Gemini model. And get this, they even looked into multimodal training with images.
Wait, images. So they were trying to give AG2 the ability to actually see the diagrams.
Yeah, exactly. That's the idea behind multimodal learning, which is this really hot area of research. They didn't go into a ton of detail about the results there. But it's definitely something to keep an eye on as AI continues to develop. So yeah, we've got this expanded domain language that allows AG2 to deal with these more complex concepts. We've got automation. It's translating problems, generating diagrams all on its own. We've got the upgraded DDR. Faster, more flexible, no more double point problems. And then, of course, we have this massive synthetic data set they're using for training and this really cool collaborative Skest algorithm for search.
AG2 really is like this huge leap forward in AI. It's not just about solving geometry problems anymore, is it?
Oh, no, definitely not. I think
Yeah.
AG2 is a really great example of what we can achieve with neurosymbolic AI, where we combine the power of symbolic reasoning with deep learning. So you get the best of both worlds, right? You have this logical deduction, but you also have the ability to understand these complex patterns.
So what does it all mean for those AI students listening, the ones who want to make their mark in this field? What should they be taking away from all of this?
Well, I think AG2 shows just how important it is to have well-designed training data, efficient search algorithms, and powerful language models. And it really underscores that if we combine different AI approaches, we can tackle some incredibly complex problems.
It's like even within AI, collaboration is key.
Absolutely. I think for AI students, this means you need to have this broad understanding of all the different AI approaches out there, and then you need to know how to leverage those strengths to come up with innovative solutions.
Now, we've talked a lot about the tech behind AG2, but I want to zoom out a bit. What's the potential impact of this kind of AI out in the real world?
Ooh, it's a great question. I mean, think about fields like architecture, engineering, robotics. Anywhere where spatial reasoning is key, AG2's capabilities could lead to all sorts of breakthroughs. Even things like materials science, drug discovery, there's so much potential there.
It's like AG2 is giving us this whole new set of tools to solve real-world problems.
Exactly, and that's what makes it so exciting for AI students, right? You're on the cutting edge of this technological revolution. The skills you're learning, they're becoming more and more valuable as AI becomes even more integrated into our lives.
That's both kind of scary and super inspiring at the same time.
I know, right? It's a lot to wrap your head around. But that's part of what makes this field so dynamic. There's always something new to learn, something new to explore. The possibilities really do seem endless. Speaking of which, when I was reading those research papers on AG2, there was something that really caught my eye. They mentioned these experiments where they tried to get AG2 to generate full mathematical proofs without using DDR as a crutch.
Oh, wow. So they were basically testing if it could, like, break free from its reliance on that symbolic engine and become this even more autonomous reasoning machine.
Exactly. And while they didn't quite achieve complete autonomy with the language model, the results they got were actually really promising. They found that with a bit of fine-tuning, it could actually produce some pretty impressive partial proofs.
So that raises a really interesting question, right? If AI is getting this good at problem solving, what does that mean for us humans? Are we going to be obsolete?
I think that's a question a lot of people have, and it's a valid one. But at the end of the day, AI is a tool. It's a powerful tool. But how we use it, that's up to us.
So it's about learning how to work with it, not against it. How to harness that power to solve problems we haven't been able to crack before.
Yes, exactly. And that's why I think AG2 is such a great example. It's not replacing mathematicians. It's giving them these amazing new insights and tools to push the boundaries of what's possible in geometry.
Collaboration, not competition.
Exactly. That's what it's all about. And I think that's a really exciting message for AI students, especially, you're at the beginning of this incredible journey in this transformative field.
So we've explored the amazing capabilities of AG2. We've dug into the technical details. We've even pondered some of the bigger philosophical questions that it raises.
Yeah.
What's the big takeaway here? What do we want our listeners to remember?
I think AG2 really shows us how much progress we're making in AI. It's proof that even these things that seem impossible, they can become possible if we're creative, if we're ingenious, and if we put in the hard work.
It's really about bringing the best of both worlds together, the human and the artificial.
Absolutely. And AG2 really highlights the power of that collaboration, both between humans and AI, but also between different AI techniques. So it's like this multi-layered collaboration, which is pretty cool.
Yeah, like AI is teaching us about the importance of teamwork, even in a field that's often seen as, all about machines. But it's really not. It's about the people behind the machines, too.
Yeah.
The ones who are pushing the boundaries of what's possible. And for those of you listening who are just starting out in AI, AG2 is a great example of what can be achieved. It's this incredible feat of engineering and creativity.
Yeah.
So what other fields do you think could benefit from this kind of approach?
Ooh, so many. I mean, just off the top of my head, think about protein folding. That's a problem where understanding these really complex 3D structures is essential, right? Or how about climate modeling? We need more accurate, more sophisticated models if we're going to tackle climate change. And AG2's approach, that combination of symbolic reasoning and deep learning, could be a game changer in those fields.
It's like AG2 is opening up a whole new world of possibilities for us.
Uh-huh.
And it's up to all of us, especially the AI students out there, to explore those possibilities, to see where this technology can take us.
Yeah, exactly. You guys are the future of AI. It's your creativity, your ingenuity that's going to shape how this technology evolves and how it impacts the world.
And for those of you who want to learn more about AG2, dig into the nitty-gritty details. We've included links to the research papers and some of the really cool solutions that it's come up with. You can find all of that in the show notes.
Go check it out. There's so much to discover, and I can't wait to see what you all come up with. It's a really exciting time to be in AI. The future is wide open.
Absolutely. And on that note, I think it's time for us to wrap up this deep dive. But keep those AI brains buzzing, everyone. There's a whole world of problems out there just waiting to be solved. And who knows, maybe one of you listening will be the one to create the next AG2. Until next time.